This is Rebecca from chemistryismyjam.com. In this video, we're going to be talking about polyatomic ions. Poly means many, atomic, so many atoms, and then ions indicates that there is a charge. So polyatomic ions are groups of atoms that stay together and have a charge. The example that you have in front of you is the nitrate ion. The nitrate ion always has a nitrogen with 3 oxygens around it, and the whole thing has a charge of -1. So the nitrate ion is NO3 with a charge of -1. Because polyatomic ions are ions, they participate in ionic bonding. In the previous video, we looked at binary ionic compounds. Those are ionic compounds that only have 2 elements. Whenever you see an ionic compound that has more than 2 elements, a polyatomic ion is likely present. The polyatomic ions are one of those things that never really go away in chemistry, so it's helpful if you take the time to get familiar with them and maybe even memorize them. There's a lot of different lists available of common polyatomic ions, and I'll put a link in the description to one list. One strategy for memorizing the polyatomic ions is to memorize the 8 version of the ions. So that would be the ions that end in ATE. All the ones that you have on the screen in front of you are 8 polyatomic ions. I have them listed in order of charge. Notice that the first 3 have a charge of -1, these 2 have a charge of -2, and the last one have a charge of -3. That's helpful if you'll sort them like that while you're memorizing them, because you need to know the atoms that are present as well as the charge. All of that is important when you're memorizing polyatomic ions. Phosphate will always be 1 phosphorus, 4 oxygens. The whole thing has a charge of -3. All of that information is important. Once you have memorized the 8 version of the ion, it's very easy to switch to the other versions of the polyatomic ion. So all of these are derivatives of the chlorate ion. Chlorate is ClO3, so it's 1 chlorine, 3 oxygens, and it has a charge of -1. You would need to memorize the 8 version of the ion. Once you know the 8 version, small changes in the name change the number of oxygens present. So for example, to go from chlorate to chlorite, the number of oxygens went from 3 to 2. So the number of oxygens drops by 1. I do want to point out that an 8 ion will not always have 3 oxygens. That's why you have to memorize this 8 version, and then to go from the 8 to the ite, you just drop the number of oxygens by 1. To go from chlorite to hypochlorite, another oxygen goes away. Going back to the chlorate version, to go from chlorate to perchlorate, an oxygen gets added. So if you know the 8 version, it's easy to change the number of oxygens to get to the other polyatomic ion. Another example, if you know that sulfate is SO4 with a charge of -2, then you can easily figure out that sulfite is SO3 with a charge of -2. The number of oxygens dropped by 1. The charge didn't change. The sulfur didn't change. The only thing that changed is the number of oxygens. In this unit, we're learning about both ionic and covalent bonds. Polyatomic ions participate in ionic bonds because they themselves have a charge, so they are attracted to other charged particles, and ionic compounds are attractions between charged particles. I do want to make a distinction though. The bonds within the polyatomic ion itself are covalent bonds because these are bonds between non-metal atoms where electrons are being shared instead of transferred. So you have covalent bonds between the atoms of the polyatomic ion, but then the whole thing will ionically bond to something else to form an ionic bond. That wraps up our discussion of polyatomic ions. Stick around as we begin looking at covalent bonding.